Hi, I'm Kwasi on top episode, second year for NS High School. Right now here, we're going on with our electromagnetic dynamics. In electromagnetic dynamics, we're currently at chapter 1, Gaussian law. Well, first of all, we can have a small revision about what we had before. So what we had before, for example, charges. Two charges, you can call them Q1 and Q2, these two charges. Then from these two charges, they're all point charges. Well, one of them source charge, another maybe the test charge, both source charge. Well, those are possible. So if we want to find the charge, or we write it as F, this is actually force between them, we'll have to use. So for this part, there are different ways of writing. It is either write it as K, Q1, Q2 over R squared, then the unit vector, or K, you write it as 4 pi epsilon naught. Then the others is the same. Or you can also change the ways of writing for the unit vector. So these ways are possible. These ways of writing, alright? So this is for the F, but just take note that for this F in this part, we're only taking for at that moment. At the instant, as we call this electrostatics, the static it shows it is only right at that moment. Okay. So another thing that we had to know is the E, the electrostatic field strength, but also take note that there's also an electrostatic. So similar to that, it is at that moment. So for this part, electrostatic field strength, you have F over Q. But just by looking at this, you may get a little bit confused between Q. Why is there a Q1, Q2, then suddenly there's another Q over here? Let me just tell you. This Q1 and Q2, there are these charges, these point charges that you have here, the total charge for that. While this Q, it shows how much amount of charge that you have, or in coulombs, in total how many coulomb charge you have. So that's what you have here. So here you can also call it a specific strength, specific force. So that's what we can call it, as this is per unit something. In this case, per unit charge, or per unit coulomb, per coulomb, like that. So this is when you use electrostatic field strength. So for now, we're just going to use these two to find some of the things. Okay, we're just using these two, for example. If we take this as an x-axis, and then we take this as a y-axis. Then for the center here, you may use O, stands for origin, or you may use P, position, point, P1, position number 1, or whatever ways you're going to use it, PO, position of the origin. Well, you may use things like that. Or even you can say as P0. So, first of all, for this part, what if our charge 1 is over here? So for here, our charge 1, which is Q1, it will be positive 1 coulomb for this part. Then after that, for here, we'll have Q2, which will be a negative 1 coulomb Okay, we can just take it like that. So first of all, they may ask you at this position or at like this. So for this part, if we were to find E vector, or this is the electrostatic field strength. So to find the electrostatic field strength at this part, first of all, there's definitely this constant in front. Then after that, these two charges. So these two charges, this positive 1 coulomb, wait, and I also have to give the length, 1 meter, 1 meter. Let's just take it like this. So positive 1 coulomb, it shows that it is a positive charge. As for a positive charge, like you can say that the forces it give will be like this. They have to be similar length. Okay, so this is for a positive charge. Then on the other side, you get a negative 1 coulomb. For negative, that means it is a negative charge. So negative charge, they have something like this. Alright, so then now you know about positive charge and the negative charge, about like the directions. So that means at this part, this positive charge pushes it away, okay? It pushes it away. And this negative charge on this side will pull it. So that means in total you have 2 coulomb force right now. So you have 2 of the force. Then you have to over. So the distance squared. Here the distance is 1 meter, so 1 squared. Well, here you have, well, 1. So then after that, from this part, you need to put in the direction. Well, the direction is just along x-axis, in fact, in the positive direction. So you're just going to use I vector. Well, let me just tell you how you get this 2 here. This 2 is actually 1 times 2, 1. Each one of them give 1, 2, well, 2 of them. And in fact, they have the same length at the same time. So after a little bit of simplifying, you get 1 over 2 pi epsilon naught, then I vector. So in the next part that we're going to have, here we already have these 2. The next part, okay, about the same distance away, well, you can't tell what that means. Let's just say here's position A, or P1, you can also use it like that, A, P1, you can just take them. Then from here you have 1 meter. Then they ask you at point A, then the question will be find, well, E vector, electrostatic field strength. Like this. So from this part E that you will have, let's take a look. Well, at the same time, you also can choose to separate them to consider. First of all, 1 over 4 pi epsilon naught. Let's just say we take for Q1 first. So Q1, 1 coulomb. Then you over 1 meter, so 1 square. Then the direction for this part goes that way. So that means you get negative. So here you have a negative to show that direction. Then for Q2, that means it pulls it in that direction. So you have to add 1 over 4 pi epsilon naught. So 1 over 3 meter distance, 3 square. still in the x direction, so there you have that I. So then this has become -1 and 1 over 9. So -1 plus 1 over 9, -8 over 9. So 8 over 9, you can simplify it here. You get 2 over 9 pi epsilon naught, not to miss out your I vector, just to show that direction. So far, it looks simple. It's either this straight line here. So it still looks simple until now, but let's take a look at what kind would I give next. I'm going to give a point here, and I'm still going to tell you this is 1 meters away. Then I'll still define at point B. Find your electrostatic field strength. How much would it be? So from here, it seems like there's a little bit more trouble. Since this is now on the y-axis, those two examples that we have done before, they're only on the x-axis, nothing related to the y-axis. But now you have something on the y-axis. Okay, so I'll give you a little time to think first, like how would you want to solve it? Okay, so right now I'm going to solve it here. So here you are having with B. So you can also choose to separate them, but let's take a look at what kind of case will we have. This is a positive charge. So a positive charge, then it will push it in this direction. In this direction over here, that's where it will push. Then this negative charge will pull in this direction. So wait, they're similar. Okay, like this. So then after that, with these two parts, how about let's separate them into their components. So this component, you have one up here, another is down here. Then for the other one, you have in this direction. Okay, so these two, one goes in positive y direction, one goes in the negative y direction. Well, since they're all 1 Coulomb force, they cancel out. Okay, so this direction we're already going to consider. But then we'll have 2 that are in this direction. We want 2 of them in this direction. So first of all, we'll still need to write 1 over 4 pi epsilon naught. So 2 in this direction. Well, how much force is that? So how about here, what angle is it? Okay, so this angle over here, you can say as 45 degrees. We can also use pi over 4. So here that means you get cosine pi over 4. So here using cosine pi over 4. Okay. So here you're using cosine pi over 4. Then times that hypotenuse. So for this part of that hypotenuse, wait, let's take a look. So the distance, you also need that. Okay, hypotenuse, well, 1 Coulomb 1. Then over square of the distance, 1, using Pythagoras theorem, you get square root 2. Square root 2, then square again, you get 2 in this part. But then you have 2 forces in the same direction. So you need times 2. And then these two cancel out. And at the same time, the direction. The direction in this case is perfectly in the x direction towards the positive. So that means it is I vector. So these two simplify it. Cosine pi over 4, well, square root 2 over 2. So you get square root 2 over 8 pi epsilon naught. Then I vector. So this is the part that you have. So at first, it may seem like difficult if you don't know about these methods. So for this last part, what we're actually using is just, well, you first find them out, in which direction. Then separate them into the components, Pythagoras theorem, cosine, and that's pretty much it. So it actually is simple, if you know the methods, of course. So for this out, we have 3 cases in this. In the next lesson, we're going to have some more others. Well, for this time, we may have many examples about these. So for this lesson here, I'm just going to end it. So if you like our videos, don't forget to subscribe to our channel. So see you in the next lesson. Thank you for your watching.